You know, when we look out at our solar system, we like to think we've got the rules figured out. Planets form from a spinning disk of stuff, and where they form determines what they become. It's all supposed to make sense. But then there's Mercury. The planet closest to the Sun seems to have torn up that rulebook. Today, we're diving into the story of the planet that, by all rights, just shouldn't be there.
I mean, that quote just nails it, right? It's like every other planet got the memo. They're all playing their parts in this predictable cosmic dance. But Mercury, it's going rogue. It's an improviser. And what's so wild is that this mystery is right here in our own backyard, forcing us to rethink everything we thought we knew.
All right, so let's get right into it. The impossible planet. Why that name? Well, it all goes back to our main theory for how planets get made, something called the nebular hypothesis.
So, picture the early solar system, right up close to the brand new sun. It's just this chaotic, blazing hot mess. And it's packed with heavy stuff like iron. So our theories, they all predict that whatever planet formed there should have been an absolute beast, a giant metal-rich super-Earth. But that's not what we got. Not even close.
And this is where the mystery really starts to deepen. The first big clue that something is way off with Mercury is its density. I mean, it's just mind-boggling. This is where the story gets really weird. Okay, so first, just look at the size difference. You've got Mercury, which is just a little bigger than our moon, right? And then you have Earth, which completely dwarfs it. So just looking at it, you'd think, okay, that's a lightweight planet. Makes sense. But it's not. Not at all. I mean, get this. Despite being so tiny, it's nearly as dense as Earth. Now that should be impossible. See, Earth gets a lot of its density because its own massive gravity is literally crushing its insides. But Mercury, it's way too small for that effect to be significant. So that means the stuff it's made of has to be insanely dense all by itself. So what on earth is going on inside that tiny planet?
And boom, here's the answer. Its core is just ridiculously huge. We're talking 85% of the planet's radius. It's basically a giant iron cannonball with just a thin crust of rock around it. I mean, think about that. No other rocky planet in our solar system looks anything like this. So the big question is, how did this happen?
Well, for a long time, the prime suspect was a really, really bad day, a story of pure cosmic violence. The thinking was, to end up with a planet that's almost all core, something must have come along and just ripped off most of its rocky exterior.
And that's the giant impact hypothesis. The story is pretty dramatic. So, you've got this young, normal proto-Mercury minding its own business, then bam, it gets slammed by a massive planetoid. We're talking a collision so unbelievably violent that it vaporized and blew away most of its rocky mantle into space, and what's left behind? That super dense iron core. For a while, it seemed like a perfect explanation. Case closed, right?
Well, not so fast. Because then, we actually went there. We set a probe, NASA's MESSENGER spacecraft, to get a closer look. And the data it sent back? Oh man, it was a total plot twist. It threw a huge wrench into that neat and tidy giant impact story.
Yeah, because when our robotic detective got on the scene, so to speak, the evidence it found just didn't line up with a violent, fiery crime scene at all.
Here's the smoking gun. A giant impact like that would create an insane amount of heat. It should have instantly boiled off all the light, delicate stuff, what scientists call volatiles, things like potassium and sulfur. They should be long gone. But what did MESSENGER find? The surface of Mercury is loaded with them. It just doesn't make sense. How does a planet survive a cosmic blast furnace and somehow hold on to its most heat-sensitive ingredients? This wasn't just a small problem for the theory, it was a massive contradiction. So, with the main theory suddenly on shaky ground, scientists started looking at everything else about Mercury. And they realized, oh boy, the giant core is just the tip of the iceberg. This planet is just a whole collection of paradoxes. Okay, first up, the temperature swings. The side facing the sun gets cooked to 430 degrees Celsius. That's hot enough to melt lead, a total furnace. But then, because there's pretty much no atmosphere to hold on to that heat, you flip over to the night side and the temperature plummets to a bone-chilling minus 180 Celsius. Talk about whiplash. It's a world of the most insane extremes you can imagine. So on a planet that's hot enough to melt lead, what's the last thing you'd ever expect to find? Yeah, water, ice. And yet there it is. Tucked away in the permanent shadows of craters near the poles, MESSENGER found tons of it.
Glaciers on an oven-hot planet. It's so contradictory, it's almost funny.
And the list of weirdness just goes on and on. It's got this wobbly, chaotic orbit that, honestly, should have been flung out of the solar system ages ago. The whole planet is actually shrinking, creating these huge cliffs as its core cools. It has a wonky, lopsided magnetic field that we can't explain. And maybe the biggest clue of all, we've looked at thousands of exoplanets and we haven't found any other Mercuries. It's a total one-off.
So, what are we supposed to make of all this? Where does it leave us? It leaves us with a planet that's not just a little weird, it's a profound puzzle. It's the ultimate exception to the rule.
And this quote really says it all. It's more than just a planet. It's a giant question mark hanging in our own solar system. Every time we learn something new about it, the mystery just gets deeper. It forces us to look at our own theories and say, okay, maybe we don't have this all figured out. Maybe we're not even asking the right questions yet.
So maybe we should shift how we think about it. Instead of seeing Mercury as a problem for our theories, maybe we should just see it for what it is, the ultimate survivor. It's a reminder that building a solar system isn't neat and tidy. It's messy, it's violent, it's chaotic. And Mercury is the little guy that somehow, against all odds, survived the chaos. It's the one that got away.
And that's really the big question this strange little world leaves us chewing on. Is Mercury just a total cosmic fluke, a 1 in a trillion accident? Or is it trying to tell us something? Is it a sign that our rulebook for how to build planets is fundamentally missing a chapter? Or maybe the whole book is wrong? For now, Mercury's not talking. It just hangs there in the sun's glare, a beautiful, baffling mystery, just waiting for us to figure it out.